In the world of AI development, everything is about speed and convenience. As an engineer, you build your code using a million dependency packages. Many of them are trusted in the community that you usually just pip install them as dependencies. You yourself would have used those packages dozens of times in different code bases developed by you. You don't poke into the different packages in detail as long as your build pipeline executes fine without any issues. Not in a million years would you expect that somewhere in that package, hidden in the base64 encoded blob, a credential stealer would wake up and start exfiltrating your API keys, your cloud tokens, your Kubernetes secrets. And the best part, you have absolutely no idea that the exfiltration is happening. Well, that's exactly what happened on March 24th, 2026 with Lite LLM, one of the most popular Python libraries in the entire AI ecosystem. Welcome to Secured by Design, the podcast where we explore how identity and wider cybersecurity shape the foundations of our digital world. I'm Santosh, and in each episode, I'll share insights and practical perspectives on how we can build security into every layer of technology and business, from identity governance and zero trust to the latest in cloud and compliance. Let's dive into what it takes to design security that lasts. Today, we are going deep on this incident that happened within a few days while we are still yet to reload from the Striker incident. But this one is different and more interesting in comparison. What happened? How a trusted security tool became the weapon? Who did it? And most importantly, what you and your organization needs to do right now to stop the next attack before it starts. Let's get into it. What is Lite LLM and why did attackers target it? Before we talk about the attack, let's understand why Lite LLM was such an attractive target. Lite LLM is an open source Python library and proxy server built by Berry AI, a Y Combinator company that acts as a unified gateway to over 100 large language model APIs. OpenAI, Anthropic, AWS Bedrock, Google Vertex AI, you name it. One library, one standard interface, all the models. At the time of the attack, Lite LLM was being downloaded roughly 3.4 million times per day. 3.4 million. That is a staggering reach. And here is the critical thing that made it such a juicy target. Lite LLM sits directly between your application and every AI provider you use. That means it often has access to API keys, environment variables, cloud credentials, and sensitive configuration data that touch multiple upstream systems at once. So when a threat actor compromises Lite LLM, they got not just one key, but the master key ring. We are talking SSH keys, cloud credentials, API tokens, etc. This is exactly the kind of high leverage, high blast radius target that sophisticated attackers hunt for. So, how did the attackers actually pull this off? Now, this is where it gets fascinating and honestly terrifying from a security architecture perspective. This was no simple smash and grab. This was a sophisticated multi-stage supply chain attack that exploited the very trust that the whole open source world is built on. So here's the clever part. The attackers didn't even go after Lite LLM directly at first. They started by hacking the CI/CD pipeline of a totally different tool called Trivy 5 days earlier on March 19th. Trivy, for those who don't know, is an open source vulnerability scanner. It's massively popular in DevSecOps pipelines. Teams use it to find security issues in their code. The irony is almost painful. The Malicious Trivy build contained a credential harvesting payload. Any CI/CD pipeline that pulled this poisoned action would have its secrets silently exfiltrated. In effect, they weaponized a security scanner. The very tool designed to protect the pipeline became the pipeline's attacker. Now, a CI/CD pipeline is just the automated system developers use to build and ship softwares. Lite LLM's CI/CD pipeline used Trivi as part of its build process, pulling it from APT without a pinned version. So when Lite LLM's automated build ran on March 24th, it pulled the compromised Trivi action. That poisoned action then exfiltrated the PyPy publish token from the GitHub Actions runner environment. With that token in hand, Team PCP, the attacker group behind this, uploaded two malicious versions of Lite LLM, versions 1.82.7 and 1.82.8 to PyPy, the official Python repository that everyone trusts. Each versions were a little different. In both of them, the nasty payload was injected right into the package's code. But the second version, 1.82.8, had a much more dangerous and persistent trick up its sleeve. They added this tiny, innocent-looking file with a PTH extension. Now, for those of us who don't live and breathe Python every day, a PTH file is a special kind of configuration file. And what it does is very simple. A PTH file executes automatically every single time you run any Python script. It doesn't matter if you're using LiteLLM in that script or not. Just by installing that malicious package, the malware was armed and ready to run in the background of literally everything you did in Python. So, the crucial part here is that this made version 1.82.8 a persistent threat. The malware wasn't just hiding inside the LiteLLM package anymore. It was now embedded in the Python environment itself. It's a brilliant, devious way for the attackers to make sure that credential stealing code was always running silently in the background. The most insidious part of this attack is that you didn't have to choose to install a LiteLLM to be a victim. In the world of modern software, we rarely install just one package. We install a tree of dependencies. Because LiteLLM is a popular open source utility, it is often a transitive dependency for thousands of other AI frameworks and third-party chatbot interfaces. If you install a trendy new AI library that requires LiteLLM as a background requirement, your package manager would have silently pulled the malicious version into your machine. The malicious versions were live on PyPy for approximately 3 hours before PyPy quarantined the package. 3 hours. With 3.4 million daily downloads, you can imagine the exposure window. The alarm was first raised not by a security team or a CM, but by an engineer at a company called Future Search, who loaded the package as a dependency via a Cursor MCP plugin and noticed his machine going haywire. A bug in the malware code kept spawning more and more processes, and hence the reason for its accidental discovery by this engineer. Let's talk about what the malware actually did when triggered. It was a comprehensive credential harvester that was designed to just vacuum up everything of value. And we're talking SSH keys, cloud provider credentials like AWS access keys, GCP, application default credentials, Azure tokens, and then it also stole Kubernetes configurations and secrets, API keys from env files and environment variables, database passwords, even sensitive data from your files. There are even some unconfirmed reports that it was looking for crypto wallets. Alright, now let's get to the part that matters most. What do we actually learn from this? I want to give you 5 concrete takeaways. Lesson number 1. Trusted is not safe. The entire Lite LLM compromise flowed downstream from trusting Trivi, a reputable, widely used open source security tool. Trust must be verified continuously, not assumed once. Incomplete remediation is not remediation. Here's the detail that should keep you up at night. Aqua Security, the company behind Trivi, had actually dealt with an earlier breach back in March 1st. They rotated the credentials, but that rotation was not atomic, meaning not all credentials were revoked simultaneously. There was a rotation window of several days, during which the attacker regained a valid token and used it to exfiltrate newly rotated secrets. One breach turned into a campaign because the cleanup was incomplete. Full, simultaneous revocation is the only safe approach. Lesson number 3. Mutable references are a liability. Lite LLM's CI/CD pipeline pulled Trivi from APT without a pinned version. That single design choice is what gave attackers a foothold. Mutable references, GitHub actions without pinned SHA commits, Docker images tagged as the latest are backdoors waiting to be exploited. Pin everything, verify everything. Lesson number 4. The AI stack is the new attack surface. We have spent years securing web applications, APIs, databases. But the AI toolchain, the libraries, the gateways, the model routers, the orchestration framework is now a first-class attack surface. These tools are high-value targets precisely because they sit at the intersection of credentials, data, and cloud infrastructure. Lite LLM is just one example. This is a trend, not an anomaly. And finally, the last lesson. Alarm systems are only as good as who hears them. One of the most striking things about this incident is where the alarm was first raised. Not via a CVE feed, not by a CM alert, but on one of Reddit community and Hacker News by an individual engineer testing a plugin. Your security monitoring needs to include the community channels where practitioners actually live. Well, this can't be automated, but yes, we need to bring it more into a process. Now, what do we do to prevent such a thing from happening again? Let me split this into 2 buckets. Immediate response if you think you might be affected, and long-term hardening for everyone. If you think you may be affected, in your terminal window or command window if you're using Windows, run pip show Lite LLM. Check your installed Lite LLM version immediately. Versions 1.82.7 and 1.82.8 are the compromised ones. If you have them, remove the package and purge all caches. Rotate all credentials. Assume everything was compromised. SSH keys, cloud provider credentials, Kubernetes configs, API keys and env files, database passwords, all of it. Audit whether your environments were also exposed via Trivi. The Lite LLM compromise was downstream of that CI/CD trust failure. So that's if you think you might be compromised now. In a long-term basis, what we should be looking at are things like pinning all dependencies, implementing atomic simultaneous credential rotation, adding software composition analysis to your CI/CD pipeline. Tools like SNCC, Sonatype, etc. can detect malicious packages at the point of ingestion. Treat your AI toolchain with the same security rigor as your production application. Model routers, LLM gateways, and AI orchestration libraries deserve the same scrutiny as your web server. Enable PyPi's trusted publishing features where available and require MFA on all package publisher accounts. Monitor community security channels, Hacker News, security-focused subreddits, and the SNCC socket feeds as part of your threat intelligence posture. By the way, Pointwild, a leading global provider of AI-powered cybersecurity, announced the immediate release of a free security tool called Who Touched My Packages, or WTMP in short, to provide developers visibility into their vulnerabilities as the result of the compromise of the widely used Lite LLM packages. It's definitely worth deploying as an immediate audit step. Here's the uncomfortable truth that I want to leave you with. This attack worked because convenience, automation, and speed won over security. And they will win in most organizations most of the time. We pull packages without pinning. We trust tools because they are popular. We rotate credentials in stages because it's easier. We build software supply chain on implicit trust. And Team PCP just showed us how brittle that foundation really is. The Lite LLM attack is not the end of the story. Team PCP is still active. More will follow, perhaps. The AI toolchain is the new frontier for supply chain attacks. And the organizations that treat it as such, the ones that build immutability, verification, and zero trust into their dependency management, are the ones that won't be making headlines. Thanks for listening to Secured by Design. If today's episode gave you something to think about, subscribe and follow on your favorite streaming platform for more discussions on identity and cybersecurity. Please do consider taking a time to rate this show. I would really appreciate that. That is one of the best ways for you to support this podcast and help grow this by providing feedback. Please feel free to share it with your team. You can also connect with me on LinkedIn for updates and new episode releases. Until next time, stay secure, stay resilient, and stay secured by design.